Hello and welcome back to Calculus 1 section 3.4 on product and quotient rules. So this is going to fill in for what we didn't talk about it in the last time we had a class. We said that we have the derivatives of the constant multiple, right? We had the derivative of product and, of sum and difference. But we did not have product and quotient. So now we have to take care of those. And these will be two formulas which you memorize, and you don't have to worry about products in the future because you would know how to take that derivative. Now, we have seen problems where you can bypass the product rule with algebra, but then there are problems where you cannot do that. So if you take a look at the derivative of, let's say, 3x plus 1 times x squared minus x, right? We don't have the rule for this, so you can't solve it using the product rule, right? Because you still don't know the product rule. But there is a thing that you can do. You can FOIL, right? Distribute, and then it will become the basic problem, which you can take the derivative. So now you would have 3x cubed, right, minus 3x squared, plus x squared, and minus x. So if you FOIL, you will get this, which is a basic polynomial, and you can take the derivative of that. Now you can still simplify this, so let's go and do that, and get negative 2x squared minus x. So now you can just take the derivative as 9x squared minus 4x minus 1. That's a 4. So you have a way of taking the derivative of a product, because this is clearly a product of two functions. But in order to do that, right, we had to be able to FOIL. Now, why do we need a product rule formula if we can FOIL? Well, if you run into a problem, which most of the problems will have exponential function, now, right, you can't FOIL. You can't multiply, you can't use algebra to turn this problem into, polynomial, because e to the x is not a polynomial. So we must use product rule formula in this case. So previous problem, you can use the product rule formula, or you can go around it by FOILing. But in the second problem here, you absolutely must use product rule formula, because there's no way around it. You are using polynomial multiplied into transcendental function. Transcendental functions are all of the e to the x and ln x and trig later on. So you have to, absolutely have to use the product rule. So let's learn the product rule. So there are three different ways that I'm going to write this formula in, and you learn one of those. No one is asking of you to learn all three ways of writing this formula. So the standard formula is to say that the derivative of f of x times g of x, so clearly you see the derivative of a product because I am multiplying f times g, is going to be copy the first function as is, so literally Control C, Control V, right? And then times the derivative of the second function, so g prime, plus copy the second function, and then take the derivative of the first. So this is known as the product rule formula. And most of the literature would have product rule written like this. You clearly see that these functions f and g that are independent of each other, right, will have, sometimes you copy it, sometimes you take the derivative, depending on where you are in the formula. So for this, you will have the copy ones, and then you will also have f prime and g prime. Another way that people write this is very frequently using the substitution. Let u be the f of x and g, sorry, v, not g, v be g of x. These are still functions, but this allows to write it cleaner, right? Which is uv derivative is uv prime plus vu prime. This is yet another way to write the same formula. And again, you have first function is u, second function is v, and then you have all of these things. So now we're going to take a look at the one more. It's the same thing over again as just using f and g. Now this one is pretty much never used, in writing, but there you go. So you see all three, and without even giving you an example, let me see if you can just figure it out on your own, right? On, let's say, the basic example here. Let's have x plus 6 times 3x squared minus 2x. So let's see if you can follow the formula, right? U and V, and then use the formula as is to come up with the answer. So I'll give you, 18 seconds, I guess. All right, 18 seconds is up because you are literally copying a part and then taking derivatives of basic polynomials, right? So copy the first, derivative of the second. Well, that's 6x minus 2. Plus copy the second, which is v. Derivative of the first is just 1. So if I write stuff from the formula, u v prime plus v u prime. It's literally this simple, right? Obviously, you must memorize the formula. Now, this is the formula that you are going to reverse later on in Calc 2, reverse it again in differential equations. And technically, if you don't learn this formula very well, right, you're going to have a lot of issues down the line. So make sure you know the product rule really, really well. Now we're going to simply FOIL this stuff here and get our, there we go, get our simplified problem. So that's going to be 9x squared, 32 plus 32x minus 12. And that would be this answer. Now again, polynomial times polynomial. We really did not need product rule because we could have FOILed to begin with. But then this next problem, right, where I introduce e to the x, is going to make a difference. So try this one. And you're using the same idea where this is your u, this is your v, or f and g, whatever formula you want to follow. Try this one on your own. Okay, so same deal. Copy the first, derivative of the second, plus copy the second function, times derivative of the first. It stays the same. It's very important to practice early on to factor your answer and simplify it as far as you can. Because in chapter 4, we are going to say equal to 0, solve the equation, and go on with the problem. So we need to practice this as soon as possible. Why is this e to the u? E to the x. There you go. So we see that both of these terms have e to the x. So we can factor that out. And in parentheses, we have x squared, 6 and 2 is 8, plus 8x. 6 plus 2 is another 8. So this is our simplified answer. And I did have a student ask about it in the other class. Do we have to do this? For chapter 3, you don't, but you will have to for chapter 4. So you might as well start practicing and doing it the right way from the beginning. There is not much more to product rule. If you are willing to learn the formula and plug everything where it goes in that formula, that's it. Now, once we learn the quotient formula, interesting problems arise. So let's take a look at the quotient formula. And that one is the derivative of f of x divided by g of x. Quotient, obviously division. So now we understand that. And again, there is a formula that we memorize. In the denominator, you have the g squared. And that's where I always start. And then I go to the top and I say g of x f prime minus f of x g prime. And then obviously you have your u form that people sometimes like better, which is going to be vu prime minus uv prime divided by v squared. Again, same thing. It's just less writing. Very important to have this g of x not be 0, obviously. Otherwise, the whole problem goes up in flames. So now that we have the formula, we can take some derivatives. Again, it is one of those where you just plug everything where it belongs. You have v, you have u, and then you take the independent derivatives on the side, and then just like little blocks, plug them where they belong and simplify. So let's have x squared plus 1 divided by 3x minus 6 to start off, and then we'll do another one with the exponential function, but do this one first. So the numerator over here is u, denominator is v, independent derivatives u prime is 2x, and then v prime is just 3, and then you plug them where they belong. All right, let's solve this. So now we have 3x minus 6 squared, because you take v as is and you just square it. There is v and then there is v prime. So obviously if it just says v squared, then you just take v as is and square it. Then take v as is and copy it here and multiply by the derivative of u. And that's 2x, because derivative of x squared is 2x. That's the stuff we did last class. Then we have minus, copy the top, that's x squared plus 1, and derivative of the bottom, derivative of v, is just 3. Now we simplify this. We have 6x squared minus 12x, and then we have minus 3x squared and minus 3 divided by 3x minus 6 everything squared. So now in the numerator, 6 minus 3, that's 3x squared, minus 12x minus 3 divided by 3x minus 6 squared. Now in some case, right, you are done, but you can still factor out 3 and cancel. So I'm going to do that because, then it's really factored to the lowest terms. You kick 3 out, x squared minus 4x minus 1. And when you kick 3 from the parenthesis over here, that 3 gets squared first, so it gets kicked out as a 9, and you have x minus 2 squared. So now this simplifies into x squared minus 4x minus 1 divided by 3x minus 2 squared. And now this is ready for you to set it equal to 0 and then figure out something that in chapter 4 will be called critical point, and you can go from there and compute more stuff. So this is where we start, right? One more problem. This one is going to be also quotient rule with e to the x, and then we can try some spicier problems. So still vanilla or a mild dish. All right. We're going to have, let's say, I don't know, 4x squared plus 3 divided by e. We can do e to the 2x. It's okay. If you did not remember the formula, the derivative of e to the ax, whatever that a is a e to the ax. So that will help you when it's time to take the derivative of e to the 2x. All right, try this one, see where it goes. All right, so let's start with squaring denominator. Then copy function as is. Derivative of the top is going to be 8x. And then minus, copy the top as is, times the derivative of the bottom. This is where you get to use this formula. You get to write the 2e to the 2x. That 2, as you can see, jumped down in the derivative. All right, so now we have all of that mess ready. It is time to simplify. Now we see that we can factor out 2e to the 2x. From the first term, you are left with 4x. And from the second term, you are left minus 4x squared minus 3 when that negative distributes to both terms. So 2e to the 2x is out, and that's why this 8 turned into a 4, because we have the 2 over there. So 2 times 4 is 8. And then 2 times, and then this 2 becomes the 2 for the second term. So we have that, and then the denominator I am not going to write as e to the 4x. I could, but I'm not, because this e to the x is canceling, as you can see, right? One of these. So we are left with 2 times, and now we can put this in descending order, divided by e to the 2x. You can still pull out a negative, so your x squared, becomes a positive value, but whatever. So that's the quotient rule. So the quotient rule is going to still have the u and a v, or f and g, whatever you like to do. And then you have your v u prime minus u v prime over v squared. It's a formula you memorize, and anytime you see the quotient rule, you use that formula, and that goes for all of your future courses. This is not just, in Calculus 1 and you're going to pass that on a test and never use it again. You are going to use these derivative rules in every course following this one. So make sure you know it very well. Very, very well. All right, so what we...
Professor, could I just ask a question?
Of course, always.
So instead of pulling out the 2e to the 2x, I just pulled out e to the 2x and I left the 2 inside. Would you accept that as a final answer once you
Yes.
Okay.
The only thing for later, you will have to work with larger numbers when you're solving equations with it in chapter 4.
Right.
Because as I said, right now we are only practicing quotient rule as this new phenomenon you guys have learned and seen, right? But when you go to chapter 4, it's just going to be one of those things that you quickly do on the side, because the rest of the problem is what takes, a page of calculations.
Right.
And doing the quotient rule. So your question is fair. I did mention before something similar. You do not have to simplify any of the answers, and it's still full credit on exam 2, chapter 3, exam 2. It's still full credit because you are displaying your ability to do the formula, right? And then whether it's simplified or not, and your ability to solve equations, that's going to be chapter 4. So it was just my suggestion, practice it now. It's easier, so you don't have to worry about it later. That's it.
Okay.
Cool.
Thank you.
You're welcome. So that's the story of the quotient rule, and that's the story of the product rule, right? So these are the two rules which you memorize the formulas the way they are, and you use them when they pop up in your exercises and so on. So now, what are these cool problems that I was mentioning earlier and things that we can do with this. Well, when you have product and quotient rule, now your problems can become something like this. The derivative of x squared e to the x divided by x plus 3. And you go, why? Just because we can. There is literally no reason. It's just, yeah, look what we can do. We can flex. This is going to be the flex for 3.4. What do you see? Can you please tell me when you look at this problem in terms of the rules?
It seems like we'll be mainly using the quotient formula and then moving on to the product one.
Excellent. That is the best possible answer that you could have given, right? If you just said quotient, I would take it and then we would have to expand. But you picked up on everything. This is a quotient rule problem with the product rule embedded inside. So this is the quotient with product inside. Now, what does that mean? So see, the entire top is U and the bottom is V, right? So when we do our formula, you take your x plus 3 and you square it. So it's going to be x plus 3 over here. And now you're supposed to take the derivative of u, because this is where u prime goes. This is where product kicks in. Copy the first, derivative of the second, plus copy the second, derivative of the first. Minus, for the rest of the quotient formula, copy the top, times derivative of the bottom. So your problem is quotient, but then there is a product inside because x squared times e to the x, right? Which was your u before. So that's why we have this product rule, and now you just go and simplify as much as you can. So we are going to distribute this, so it's going to be x cubed e to the x plus 2x squared e to the x. That's when you multiply that way. Then we multiply by 3, so plus 3x squared e to the x plus 6x e to the x minus x squared e to the x. And then denominator as is. It's just a lot of nasty algebra. It's just not a big deal. E to the x gets kicked out. And then if you take a look at every term, it has 1x everywhere. Actually, you know what? Let's first add like terms. Do we have like terms? Yeah, we do. This has x squared, x squared, x squared. So we can combine all of that mess. And then we'll factor. So 2 plus 3 is 5, minus 1 is 4. X squared e to the x. And then we have plus 6x e to the x. And then we have x plus 3 squared. This is where we pull out x e to the x in front of the fraction. And what's left is x squared plus 4x plus 6 divided by x plus 3 squared. So once you do this factoring, right now when you set it equal to 0, it's a joke. right? X equals 0 is the answer. This one has no solution. And then this equal to 0 is going to be quadratic formula. And then the bottom, right, when you cross multiply, it goes to 0. So it's really easy to deal with a problem once you factor it out. I mean, good luck saying equal to 0 here and then figuring out that equation. So here is the problem one more time. We had the product rule inside the quotient rule. So we did the quotient rule as a main problem because the entire problem looked like a quotient rule. And then we went in and we did the product when we had to take the derivative of that, the product of those two functions, x squared and e to the x. Now, obviously, this can go the other way around. I'm going to encourage you to try this at your own time later, because I want to also talk about tangent lines and stuff like that. So if you take a look here, you can have the derivative of, and then now let's say you have x squared plus 1 divided by 4x minus 6 or minus 5. So it's not factorable. There we go. 4x minus 5. And then all of that times, let's say, e to the 4x. So I would like you to do this for homework as a practice, right? But this is the product rule. Product with quotient inside. So you will say copy the first, derivative of the second, plus, and when you say, well, copy the second, derivative of the first, that's when the quotient rule kicks in. So you will see that, you will see that when you try this problem at home later, whatever. I mean, if you care. If you don't care, then why should anyone else care? I want to talk about tangent lines because tangent lines are and always will be the most important part of Calc 1. Tangent line has a slope which measures instantaneous change. We talked about it many times. So now we're just going to enforce that. And we're going to solve a problem which will have, let's see, the tangent lines. So equations of tangent lines. Let's do the simple one, for instance, 64. I'll leave you to deal with the spicy ones. So find a tangent line for y equals e to the x over x at x equals 1. That's it. That's all you need. You need a function and a point at which you are looking for that. So the rule for the tangent line is always the same. Find the derivative, plug in 1, that's your slope, plug in 1 in original problem, that's your y, you have x, y, and slope, get your b. It's always the same procedure. So we need our y prime first, and that's going to be the quotient rule. So square the denominator, put it up as is, derivative of the top, which is e to the x, minus, copy the top, e to the x, derivative of the bottom, which is 1. We kick out e to the x, and you are left with x minus 1 over x squared. So this is your derivative. And I'm going to write this in blood right here. Slope of the tangent line is your derivative computed at value a. So slope for my problem is e to the 1, 1 minus 1 over 1 squared, which is a big fat 0, right? Because e to the 1 is e, and then 1 minus 1 is 0, divided by 1 is still 0, e times 0 is 0. So I have that the slope, right, this is 1, slope is just 0. And then we compute our y. Now that's just going to be f of a, which is f of 1, So e to the 1 divided by 1, and that's just e. So now for your y equal mx plus b formula from algebra 1, you have x is equal to 1, y is equal to e, and slope m is equal to 0, and you are looking for b for the tangent line. Plug everything in. E is equal to 0 times 1 plus b, so b is e. Tangent line at x equals 1 is y equals e. It's a horizontal line. It's a horizontal line, y equals to e. Remember, your slope m is 0. So you're not going to write y equals 0m plus b. Yomb. Yomb? Yomb, I guess. Right? So 0 times, I mean, yoxb. So you are not going to write m equals 0 there, because 0 times this x altogether is 0, and then plus b is altogether b. So that's what it is. That's what it is. So y equals e is our answer. Now what you can do, what we should do, is we should graph both functions and make sure that this is true, right? That this one has the what we call horizontal tangency, right? And to do that, you can just go and get the let's go with, do I have this one now? No, new window. Let's go with the Desmos. You should be using this website every day until you learn graphing by hand. So we have a graphing calculator here, and we are going to graph both of these functions. So we have e to the x. So this is going to be e raised to the x. There we go. All of that divided by what was that? It was x, right? Yes, just x. There we go. So this is your function, but then here I'm just going to graph e. Now, why is it not graphing e? Can I do y equally? Maybe y equally. There we go. Much better. And as you can see, the red one, color-coded red on the side, is our function. And you see that, right, exactly at 1. You see where 1 is on the bottom of the screen? You go up. For x equals 1, you have your 2 point, and they give you also on the side, right, 2.718. That's your 2.71828, right? That's your value for e. And they perfectly fit, right there at 1, e. It's a tangent line, which means later on we'll see, right? It's a minimum there. That's actually what chapter 4 teaches you, that you have a minimum, local minimum at that value. But that's chapter 4. So we are able to find the tangent line, and then again, as I said, those of you who care, want to do well and understand the concepts, because you understand that Calc 2 is coming up and all that stuff. Understanding this is very, very important, and then you have software and opportunity to check your work and make sure that it's great. Obviously, if you came up with the graph, looking like, let's say, looks like this, right? And then your tangent line ended up like that, not even touching the graph, you know that your answer is garbage, right? because that's not what tangent lines do. Tangent lines have to, what we said earlier, kiss the function, right? So at one point only, they touch at one point only, and at that point, tangentially, which means perpendicular to the curvature. So it is okay for me to have function like this, and if I go at 1, as you can see, we had our e. If you go, let's say, a half, you would have a line that looks like this. You go a little bit higher, right? The line would go like that. You always have one tangent line per x point you pick to solve for. Now they picked in problem 64, they picked x equals 1. So you solved your problem for 1 and you got your horizontal tangency. But if you pick any other number, it's not going to be horizontal anymore, right? So that's technically it. So I hope you are not disappointed, but that's the product and quotient rule, and you can use them for your tangent lines as well. So tangent line problem should be there, persistent in every section all the way to the end of chapter 3. Well, not all of them, but when we do the related rates and so on with the word problems, it's not going to be center of attention. So that's it. Bye.